In this video, we complete step 32, the diff method. So the diff method subtracts the current value in a particular column from the nth value above it. So by default, n is going to be equal to 1. So whatever the current value is, it'll just look right above it, and it'll subtract that and report that as the difference. It will return a data frame with the same number of rows and columns as the original. So this is actually a good one to see before we embark on it, since it's a little bit hard to explain. Let's go ahead and go into the Jupyter Notebook. I've created a new data frame that's similar to the one that we have been using for the entire project, but it has one more row, and I got rid of one of the string columns, and I got rid of all the missing values. So here it is. So I'm going to call the diff method on this one, not df pandas, df final, called diff. By default, n equals 1. I will go ahead and put that in there just so we can see that indeed n equals 1. And I'm going to run this. So what happens here is that, say, let's take the height column for instance. It's going to go through it's going to go through every value at a time, and it's going to subtract whatever the value is above it, and it will return that as the value for the new column. So for instance, 3.6 has no value above it, which is why there's missing values for the first row right here. 8.5 does have a value above it, so 8.5 minus 3.6 is 4.9, and then 5.2 minus 8.5 is negative 3.3, and so forth. So Booleans are treated as 0 or 1. Weight is going to be a little bit easier to calculate since there's just whole numbers over here. So 50 minus 40 is 10, 45 minus 50 is negative 5, and 100 minus 45 is 55. So all of the columns will be turned into float columns, as you can see, and that's because of these nans, and there is no nan or missing value representation for integers or for Booleans, so we have to convert them to floats. So let's take a look at what happens when we say n equals 2. So when n equals 2, the first two rows will be filled with nans because we're gonna have to hop back up two rows in order to make the subtraction. So here 5.2 is the first value in height where nan can be or where the diff can be computed. So 5.2 minus 3.6 is 1.6. 10 minus 8.5 is 1.5, and so forth. So that's how the diff method works. So let's go ahead and fill this out. So what we're going to do here, there's actually a function defined in here. So this is the function that we're going to pass through the non-ag method that we completed before. So we're going to use, diff is a non-aggregating function, a non-aggregating method, but NumPy does not have there's no diff function in NumPy, which is why we're going to create our own, and then we're going to simply pass that function into non-ag. Okay, so this will take, let's say, some variable called values, which will just be a single column, or we've been using value. I think in my solutions I use values, but either one is fine. So the first thing we're going to do is we're going to convert this to a float. So if it's a Boolean, we're going to convert it to a float. If it's an integer, we're going to convert it to a float. So we're just going to force this to be a float, a float column or float array. That's the first thing we're going to do. So we're just going to reassign it as a float, and that's because of those nans. The next thing we're going to do is we're going to shift this array using the roll function of NumPy. So I'm going to call this value shifted, and I'm going to go ahead and roll this function. I'll use the roll function. So this will do kind of what it sounds like it's doing. It just shifts an array, and you give it the number of the shift over here. So let's go ahead and do value, comma, we're going to shift this over n, so whatever n is. Just going to roll that. And then we'll just perform a subtraction here. We'll say value minus value shifted, and that should work. Now, when you roll this function, so the roll function in NumPy, and it's probably good to just see what happens here. So let's go back to the Jupyter Notebook, and let's go ahead and roll like the weight array, so you can see this happen. When you roll this, so we'll just roll it 1, what happens is the very last item actually moves to the front. And the others just get shifted down 1. So if you roll it 2 times, then the last 2 values now become the first 2 values. You can also shift by a negative number. You can shift this way, so the first value goes to the end, and the other ones get shifted to the left. So we will go ahead and just reassign this to value. So this is what we want to return, but it's not quite right because this will not have any nans in it. So we're going to have to replace the first few values, or the first n values, with nan. So we could do something like this. Value, you could say the first n values will be np.nan. So we're going to make it equal to, we're going to make them nans. But we are going to allow n to be negative. So this will work if n is greater than or equal to 0, we'll say. If it's less than 0, then we will have to go from, so if n is negative, so like -2, then we'll go from the end all the way, or from n to the end, and we'll make that equal to np.nan. So there's different logic based on whether n is positive or negative. Which one will be, which values are we going to force to be nan? Okay, so I think that looks like it works. And then we'll just return, in this case, just the value, which is that array. So again, this is an internal function underneath the diff method. So this is going to sort of be written in place of a NumPy function. So we don't have, NumPy does not have a diff method for us. So we're sort of creating our own, and then we're going to pass it here. So n is in here. It's also over here. So the scope of Python allows us to do this. So once we define func, n will get transformed to whatever variable our user gives us. So we don't actually have to pass it along here as n. It will already be carried with it correctly. So this looks like it should work. Let's go ahead and test it out in the notebook. So df and not df final. So this is what we just implemented. So if we do df.diff, it looks like that looks good to me. We could do it with 2. So I think that looks good. All right, so we wrote like an internal function, and then we are going to make a call to the non-ag, which we did in the previous step. So let's go ahead and run this. Let's say test diff, and looks like we passed. Okay, fantastic. Looks like this amount of code has completed step 32.